Well, as this video is going to go through 2018 short questions from section A. For A1, the first one tells us a 3D graphic below shows a proposed design for the new Children's Hospital in Dublin. It consists of an ellipse and two inner circular arcs. The drawing on the right shows the major and minor circles for the ellipse. Portions of the ellipse and of the inner arcs are also shown. Part A, locate the remaining points on the ellipse and draw the curve. So basically we're looking at the concentric circles method, and what we need to do is we need to just divide up into 30/60. Let's use my 30/60 set square and take all my points through there. Let's move this down a bit. And the last one is this one here. So the next thing I need to do is I need to take my points up and across. So up and across there, up and across here, and same on the opposite side. And then up here, and now the ones that need to go across. So take that across there and there, take this across here, and then the upper half of the curve, that taken across there, that's already given to me, and the top two are there and there. And now I just label all my points here, and now I need to draw in my freehand curve then as a result. So nice and neatly draw it in and keep it as one continuous line. So that goes around there like that, and then finally the top half of the curve goes around like that there, and that gives us the ellipse. Part B, locate the focal points of the ellipse. So very simple, going back to our junior cert, we take half the major, swing it from the minor, and we get a focal point there and there. So that gives us F1 and F2. The last part, part C, locate the center point for the lower arc and complete the drawing. So we all know that an arc is just a portion of a circle. For example, if I just drew that there, that would be an arc. And we know as well about a circle, or the arc in this case, that if we join a line through the circle and we bisect that line will go through the center of our circle. So that's what we're looking for. We're looking for the center point. So if I take that there, that's a chord. If we imagine if I just drew a circle up here, that's a chord. We bisect that chord, somewhere along that will pass through the centre, and we're really giving our centre lines. If I drew my centre line there, that would then give us the centre of that arc, and we could draw the other one then as a result. So I need to bisect that first. So take a distance greater than halfway, swing an arc above and below both sides, just like that there. And then very simply connect them together, and then if I extend it on, that'll give me the radius of that arc there, which is already drawn. What I need to do is just basically take that radius there, take that distance there and step it up the opposite side, because I'm swinging the one below. And now what I can do is I can stretch my compass out to there and draw in my arc there, which completes the question. So that's the first part. A2 then, just need to move this down so you can see it. So for A2, 3 stone containers for growing flowers are shown in the 3D graphic below. The containers are in the form of geometrical objects which are in contact as shown. The drawing on the right shows the elevation and partially completed plan of the objects. The arrangement consists of a cylinder, a truncated cone and a hemisphere. Part A, draw the plan of the cylinder B. So if we look down on top of the cylinder, all we see is a circle. And we can see that there's no hidden detail, so we know that that cylinder there is right in line with the truncated cone here. So very simply just extend my center line out. There's my center there. And very simply, I just need to have my radius there. And I just go slightly behind it for hidden detail, but still sitting as an edge view in the elevation. And just rotate that around the rest of the way. And there's my plan. Then part B, draw the plan of the hemisphere C. So we can see there, it's sitting in front of it because we can see that there's hidden detail behind the hemisphere for the cone. So what I need to do is first of all take an edge view of that hemisphere. So very simply, I'm going to draw the hemisphere as if it's to the side. So what I'm going to do is, I'm going to have this point here touching off the edge there. So very simply, take the radius of it and step it across from the edge there. And what I get is, I get an edge view of the hemisphere there. I then take that down into my plan, and what I need to do is, I could redraw it there, but I'm just going to simply rotate it into the position that I want it to be in. So taking my center here, because I'm rotating around the truncated cone, where it stop, I get my original radius here. There it is there. I can just join my centers. And now I can just simply take the radius of my hemisphere. It's been blocked underneath by the truncated cone, so that's hidden detail there. And the rest, very simply, is going to be heavy. And that's the plan view of the excuse me, the hemisphere. And that completes A2. A3, we just move back up. I'll just move this across so you can see it. Just move it a little bit further. That should be far enough there. So for A3, we can see that the image below shows the Mary McAleese Boyne Valley Bridge, a suspension bridge across the River Boyne in County Meath. The drawing on the right shows the plan and a partially completed perspective view of the concrete tower part of the bridge. Complete the perspective drawing of the bridge. So, what we need to do first is, we need to extend this line down here. We don't know where it's going to stop yet. And we can see that the top part here is joining back to our vanishing point. So we can see now that hits off there. And figure out how wide this part is. We join it back to S, which is already done for us. And we take that down perpendicular to the picture plane, giving us this width here. And very simply, we just connect these two together here. And then the next part we need to do is, we need to take the inside point, which connects back here. So we want to look for the internal corner here at the back. I need to join that back there, where it hits the picture plane. Take that straight down, and where that hits our back surface here, we need the ground point as well, so that can extend down to the ground too. So make sure I line that up. That point there, and they then connect together, giving you that line there as a result. And that very simply completes that question there. The last one then, A4. We're given the image below shows a concertina. The instrument is hexagonal in cross section. The plan elevation and partially completed end view of the instrument, are also shown. Part A, complete the end view. So what we need to do is, we need to take across our points, rotate them around to draw up, because you can see it's slightly tilted. So what I'll do is, I'll work on the front part first. So currently I have the first 2 points here on the front, and I need that point there and that point there. I need to rotate those around now. So my compass there, I need to rotate that into position there. Oh, wrong one. And this into position there. And take those two straight up. What I have now is, I have my bottom point here, and I can now draw the outline of my hexagon heavy there, because if we look in this way, we can see that front surface here, but we can't see the back surface. Now we do the same with the back surface, rotating it around. So for the back surface, we're given the back two here, so I need to rotate around my other 2 points, which are going to be, I just line this up first, going to be that point which is touching off the plane, and that point there. So rotate that around there, and then this around there. And those 2 points now can be taken up. So that one there, which is going to be on the ground anyway, and it's going to be in the top there. And then this point, which is going to be connected there, and that's going to be in hidden detail there and there. We won't be able to see it. And then finally, we can't see this wall, or sorry, this side going along there, because it's been blocked, but we can see this line here along the other side of it. See that nice and clearly to there, and that's going to be hidden detail just in there. Next part, draw the true shape of the end of the instrument. So the way to do that is, look in perpendicular to it. If we look in perpendicular, we can see a true shape. And by looking in perpendicular in the plan, we can get our heights from our elevation as a result. So just extend all these points up first, and then take my XY line. Just very simply take it about here. That's X and Y one. And my heights are got from my elevation, so the 2 points on the ground and the 2 heights up here. This height marking there, and the 2 in between are going to be marked as there and there. Just need to extend that up a bit further to hit it. And then what you have is, you have your true shape drawn then. Another method would be just to rotate it out flat, so basically rebat it so that this flips out flat on the table there. But there's no need to do that. We can do an auxiliary view here showing the true shape, so we just put in TS there for true shape, and that completes the question there. So hopefully that video helps anybody who may have been stuck on any of those 4 questions.